Okay, so of the 260 people who ate at the Mellow Mushroom on Friday night, 128 bought pizza and 86 used a credit card. Sorry, I had some recording issues, so the problem is kind of already done, but it wouldn't record the sound. So 128 bought pizza and then 86 used a credit card. So what we've got here is half of the people who bought pizza used a credit card. So even though we've got 128 for the bought pizza, what you can do is cross out the 128 and just have 64 that only bought pizza, and then the other half is actually did both. Okay, so there's kind of two ways you can look at this. This you had 86 that used the credit card, but remember 64 of them did both. And so 22, once I took 86 to minus 64, 22 of them only used the credit card. Okay, so this is how the Venn diagram should look. Okay, now how is this going to play into calculating the probability that a customer bought pizza or used a credit card? Okay, so if they bought pizza or used a credit card, what we're doing here is we are making sure we're adding all of these guys together. Okay, we're adding 64 plus 64 plus 22. Okay, now the thing though is you want to make sure, like if we were to add, let's just double check this. Okay, what's 64 plus 22 plus 64? Okay, now notice, oh, I missed the 128. 128 plus 22, no, 86. Okay, so if we were to just add these two, 128 and 86, what we would have been doing is double counting 64. We would have counted them twice, okay? Because if you're going to do the Venn diagram right, you only want to count him once. So it would be 64 plus 22, okay? And so that would be it. If you were to add 128 and 86, that's too high, okay? You would actually have to do this. 128 plus 86 and then subtract the 64 that did both, okay? And you don't want to double count. And so you'd get your 150 right there. Now this adds up to 150 as well, okay? So here we had to subtract the double count if we added the totals, but if you do this Venn diagram correctly, okay, you can just add all three of the groups just right, okay? That's going to bring you to 150 out of 260. We have no idea what the other people did, okay? So 150, we just know that they didn't order pizza and they didn't use a credit card, and that's all that matters. So we're looking at around 58% did that, okay? All right, so moving along here. Okay, this looks like some basic marble stuff. The bag contains 3, 6, 4, 3. All these, what does that add up to? 9, 13. That adds up to 9 to 7 is 16. Yeah, 16. So we got out of 16. All right, and let's just see what happens. One marble is selected at random and not replaced. What is the probability that one of the marbles you choose is red and the other is blue? Okay, so remember, we got to do two different situations here, okay? We have to make sure that we add the probability of getting a red out of the first group, okay, and then blue out of the second, okay. So what is the probability of getting a red or blue for the first one? Okay, what's a red or a blue for the first one? It would be 3 and 6, so red or blue, that's a total of 9. Okay, so 9 out of 16 for a red or a blue for the first one. Then, what I will do then is I will go ahead and multiply by the probability of the second one, okay, a red or a blue. But now we are missing a red or blue, so now we go to 8, and then we are also missing the first marble, okay? So this is going to be 78 out of whatever 16 times 15 is. That's 240. So let's go ahead and do 78 divided by 240 is going to be around 33%. Okay, so 1 and 3. A jar contains 20 jelly beans. There we go, all divided in 4 colors. What is the probability that you select 2 green or 2 purple? Okay. Now, it doesn't say whether or not they're going to be replaced, though. So that is assumed that you will not replace it because you're going to select just 2 green. Let's get the first event. 2 green. First one would be 7 out of 20. Okay. Then you select the next one, which would be 6 out of 19. Now that's selecting the 2 green. Now let's go ahead and it says, or let's get the 2 purples. Okay. So now we got 6 out of 20. Okay. But then we're going to multiply by 5 out of 19. Okay. So this is the green or this is the purple. Okay. We're going to add those 2 together and we'll see what we get. So they're both going to be 20 times 19 is going to be 380. So 380 plus 380. Okay. That's going to be 42. And that will be 30. So add those together. You're going to get 72 out of 380. And 72 divided by 380 is about 19%. Okay. A basket contains 16 bags of snacks. Bomb, 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 bomb. If you replace your first choice, what is the probability that you pick a bag of chips and then a package of crackers? That's actually easier. What's the probability of getting that bag of chips? 5 out of 16. Whoops, I don't know why I wrote 15. 5 out of 16. Okay. And then a package of crackers. Okay, so what are the crackers? If you replace your first choice. Then let's get cracker 3. Okay, so 3 multiplied by 3. It doesn't say or. Okay, this says and then. So now it's going to be 3 crackers. Is it out of 15 or 16? And if you do replace, then you are actually going to be out of 16. Okay, so we've got 15 out of 16 squared. 15 divided by 16 squared, okay, is 6%. All right, 0.0. Oh, there you can see that. Yep. Okay, so around 6%. All right. Okay, we'll stop there.